There we go.
Testing.
Welcome.
Words.
Can
you hear me? Am I on?
Okay. I'm up. You're up.
Good. Yep.
I'm up. Your screen.
Is it on?
Yeah. I can see stuff. Welcome everybody. I think we're the last talk of the day. Are we the last talk of the day for you? Okay.
I'm sorry. So it's late and we're tired, but it's going to be an awesome talk. We promise. We promise. It's 420. Yeah.
So this is Damian.
It is 420.
David. We work on the .NET team at Microsoft. It's our first time in Australia.
It is.
First time back for me in a little bit. So the idea for this talk was .NET 8 is a really big release. Like most of our releases every year now are really large. And often you might, if you just watch the blog posts or you just watch .NET Conf or some of the major announcements, there's probably a lot of stuff you're not getting information about. And so we figured, we would just have what's the qualifier for getting in this talk? Stuff that we thought was cool, stuff that we like. And so that's really it. So we're going to show a whole bunch of stuff. We'll see how much Fowler can code. I've told him for all the stuff that's in this deck, there is literally no way anyone humanly possible could write a demo for everything in this deck. But he's taking that as a challenge. So I don't know how this will go.
We'll try.
All right.
So if you don't know, there's the .NET 8 blog post, which has kind of the top user-facing items that we kind of shipped. So you won't see the features that are very specific to one area or the other. There's also this What's New in .NET X doc on Learn, which is exhaustive. So there's runtime, SDK, C#, whatever version we're at. We're at 12 now. .NET Aspire. Woo-hoo. Yeah, who's came to that? ASP.NET Core. Woo. Maui. Woo. Even excitement for everything else, right? I can't have favorites. EF Core, woo! Web Forms, woo! LPF, etc. So you can, hey! So you can come here and dig into individual changes of every part of the stack, right? So if you get bored one day, or if you don't have anything to do, you can kind of turn on here and just read things like different instructions, AVX. 512 ISA instructions.
This is
everything is there. It is detailed, right?
It's a little more palatable than Tobe's post might be. So like Tobe's post is an incredible epic every year.
Has everyone seen Stephen Tobe's blog post? That like epic every single year he writes this like tome.
So when you say exhaustive, it's not that exhaustive. Like it literally exhausts you to read it.
It's not tiring to read.
But this is, look at the scroll bar. It got small,
more summarized. Right? It's kind of small here, right?
There's lots of stuff going on.
So we thought we'd go through, and I will attempt to show these in a bit more detail, if I don't fail horribly. So how many of you have used C# 12?
Okay.
11?
That's last year's version.
10?
That's the year before, .NET 6.
Okay.
All right. And there are no supported versions before that, because .NET 6 is now the earliest supported version of .NET other than .NET Framework. And .NET Framework only supports C# 7.2 or something? 7.1?
Yeah, 7.2.
Officially.
Good guess. All right, so I have two projects here. I have this console app and a web app, just at the scratch pad for showing features, right? So these demos aren't persistent. They're not planned. They're just we're going to, on the fly, code together, right? You're going to help me. Perfect.
I thought you meant together, everybody.
Zoom in.
Fonts.
You can't see my amazing...
fonts. There you go. Lovely.
Good? Perfect. All right, so the first feature, my favorite C# feature, second favorite maybe, is Mads here in the audience somewhere. He is there. Look at that, Mads is there. Mads works on C#. He actually helps us build the language. Say hi, Mads. Hey. Okay. So you might be used to building classes like this. This is I'm going to have a class, and I'm going to have some properties. This is going to be a very generic name, points, and it's X, Y. And you're going to have some properties here. So everyone types prop, tab, because that's how you do it really quickly. And X and Y. And this is noisy. Right? This class is kind of chunky and big. What if I could just do something like this? Oh, that I could just, and I can write a code fixer, but I'm going to
do it
kill
by hand?
time by typing it by hand.
You could have saved a lot of time. You'd be done by now.
Look at Copilot. Amazing. So there's a feature called primary constructors that lets me, if I have a single constructor, I can just, by shorthand, type this syntax. Beautiful, right? Time saving. If you do dependency injection, and you have like long constructors, and you're declaring all the things and declaring fields, and there's code fixers to kind of flip between primary and non-primary, convert to regular, old school, no offense. Primary. So you can jump between both patterns. Few things to know though, these aren't exactly equivalent sometimes. So let's say you were doing something like, let's call this foo. Let's have a reference type this time. I'm going to take in an object. Oh, right. Wow. Normally, you want to do some kind of checking for null, right? So you would have your class, and you would take in some object O, and you would have code like private O. These names are awful. O equals O, or
that's not bad. That was good.
All right, so you want to have this code in your app. So how do you do the same thing when you have your constructor up here? Whoa.
I mean,
that's interesting. I guess
that does work.
That's pretty equivalent. So yeah, I didn't even know to do that, but yeah, you can do that. A pattern you'll see also that's pretty common is people kind of are using a pattern where you don't have properties maybe, but you have fields. So you may have a private object, object O, that's assigned to in the constructor, the same as you have like this. And you can do the equivalent refactoring, hopefully. Help me out, help me out. No, that's not right. But I can copy this code. I can do object O. And then I can take this, and I believe do this here.
Right.
And this gives me the equivalent feature. So if you want to do null checking, this is kind of the new pattern when you want to write that logic. But you can only do certain things. So you can't write arbitrary code that checks all the fields in this one place. So if you do want to do checking on multiple fields in the constructor, you still have to revert to the old thing, right? But don't worry, Matt is going to fix that in C#13. He promised me. So
with the triple bang operator?
Yeah,
Oh.
exactly.
Sorry, too soon.
This is the new syntax we're thinking about from not no, maybe no. Yeah, okay. All right, this feature is super useful for controllers, for Sigma hubs, for basically
Razor pages,
dependency injection, pages. Actually, for pages, you don't
page models.
Page models. Yep. Okay, there you go. So that is one of the best features I think in C#13 that we've had. And it's funny, that feature came out in the first time in preview in C#6 because in the beginning of ASP.NET Core, the ASP.NET team pulled in the C# compiler, the compiler that was not done yet, the preview compiler, and we used it everywhere. And then the feature got taken out, and we had to undo all the code. Painful for that one dev who had to do it that work. But all right, so we got our first favorite thing. Let's do the second favorite thing. That's one. How much time do we have left? Kind of time.
Okay. That demo took you 8 minutes.
I'm just gonna go faster. Okay. How many of you have done this before? Like, let's declare an array, right? New array one. Oops, I love Composite.
I think this is my favorite feature. The first one was your favorite feature. This is my favorite.
This is yours?
Feature.
Okay, you get one sometimes. All right, so here's my array, right? I'm going to print the array. I just thought it. This is creepy. I don't even know what this thing is doing. Print the array. This is like normal syntax for declaring arrays, right? And you can have numbers in here. But it infers a number from having the number of elements in the array at compile time. So now I can just, and if you realize that we have been building tooling to help you make your code more modern to use new features in C#. This wasn't always the thing we did, but we've been doing it more and more as we add new features. So you have a new team and you want the team to kind of learn new features, or you want to have standards, you can actually configure these fixes to say, I want to use C#X or these features, and then the tooling will kind of help you either revert or keep use syntax. But this one I think you should definitely use. This is like
so good.
Noise reduction to the max. All right, so this looks pretty simple. It's an array on this side, so obviously it's an array. It's inferring that it's an array and you don't have the new syntax, right? That's all inferred. But what if this was not an array? What if it was a list? Still works. And this is where the magic comes in, because the compiler is looking at the target type on the left-hand side and determining what should happen on the right-hand side. And because the compiler is super smart, it can do insanely efficient things that you can't do under the covers. I mean, you could probably try to do it if you look at the code gen and stuff, but it's really clever.
So you said target type, but then you said left-hand side. What about in other target type situations?
Ooh, so what if I have a method? I guess I'm using foo. Anyway, it's fine. Let's call this, it's taking a span, right? Let's call this sum. And if I call it sum, Copilot is going to do something insane for me, probably. Okay, right, there you go, sum. It's going to complain because,
You did an array of spans.
Oops.
Yeah.
Thank you.
It's nice having the language design architect in the room for you.
Pressure, I feel pressure. Don't mess up.
So you've got Copilot.
Teachers
you've got
teachers
in the audience. How can you get anything wrong?
Teachers watching me. I need to not mess up. Okay.
Talk about safety nets.
All right.
Just call you Pilot. That's nice. What does that make? Never mind. We want
passenger, backseat driver. Okay, so I can do sum 1, 2, and I can infer from the arguments what type it should create.
So, okay, that was cool, but that's still a concrete type. What if it was like not a real type, like a contract for a type, like an interface?
Oh, Copilot went crazy here.
What if I want to take in something like a read-only collection because I want my method to just be like, I don't really depend on an array. I don't depend on list.
Good point. Because
it couldn't possibly work.
As engineers, you want to build the most generic function. So you want to have an I list of T, right?
Well, I'm not adding to it. I want it to be read-only. Does that work?
PM with the requirements. I'm just like trying to get my job done and go home. All right.
Okay.
So you get
impressive.
And this is done via contract. So the compiler can I think for these methods we have knowledge of read-only lists and a couple of interfaces, but any type can declare an attribute for how it can be constructed. So you can this can actually be which no one uses in here. I bet no one uses this API. Put your hand up if you do. What? See? Maths, you don't count. This also works.
That's amazing.
Super cool.
Very cool.
So there's this uniform way of creating a collection everywhere. One really cool pattern that I love using this API is, let's say you had a method that was going to get a list from somewhere else and it could be null. Normally, you would do something like, let me create some scaffolding here. You're watching me stumble through coding. So public task of list of person. And Copilot is so smart, it's going to just create this for me. Don't do it though. Give me a person. Are you guys on this stuff yet? This is like the future. I'm going to do all my thoughts from now on. Get people, and I'm going to just return. Okay, that too. Let's just do that. Let's do that. But let's assume this can be null. So you may have code like this, right? Like people, get people, right? Asynchronous. You can do this stuff.
Yes.
And it's super efficient. So before you would have had, maybe you would have written this code, like new list of person.
But if that's in a method, it would be every single time.
It's noisy, right?
They called it and they
So it tries to do the most efficient thing. So if I do this, it would be a new list. If this is an array, right? Oh my gosh. This will work too, right? This should work too. What's it complaining about? Is it?
Line 12, curly brace.
Line 12, curly brace.
Curly brace.
Where?
Line 12. On the other line 12, that line 12. There you go.
It's lit. Almost works.
Almost.
What's it complaining about?
Type arguments cannot be in.
Oh, it can't figure out. Mads. So this does the most efficient thing and is the equivalent of array, dot empty of person, right? So the compiler is doing its best to generate the most efficient code for every scenario. You can't outsmart it.
What did it do when it wasn't even a concrete type? When it was a read-only
Moving
list? Okay, never mind. Go on.
It creates a concrete type.
Wow, that's amazing.
Specific that actually implements the interface.
That's like my favorite
on
part
the
of
fly.
the feature. I love that.
You have a question? Yeah. I'm pretty sure if it can be allocated on the stack, it will be. So it will stack alloc if it can. If it can't, it has to create an array. So if you're doing an array of a span of objects, it can't stack alloc arbitrary object. If you're doing a span of int, it can do a stack alloc in that situation. If it knows you're never going to capture that state and return it or store it on the heap. Yeah. So it does really cool, efficient things. I burnt so much time talking about one feature. Inline arrays, am I going to show this? Probably not. It is super obscure, but it is a super cool obscure feature that I like. All right, let's do one more C# feature that is new that I believe was done by an intern and then made real in a later release, but it was the same like the intern code that we wrote. So
that's cool.
In C#6, we introduced. Oh, one more thing about. Okay, one more thing to add. This does not work yet. We want this to work. This is amazing. Like this is like JavaScript, right? I mean that's not amazing, but this is amazing. What type should this be? Should it be an array? Hands up for array. Should it be list? Only one? Okay, interesting. So, fired. Okay, Maz, got feedback? That was a survey. All right, we're good. We're good. We were at default Lambda. So in C#6, we could do this. This is very Haskell-like. It's amazing, right? Inline function, and I could declare Lambda, and it will infer what the type is going to be. So f is going to be a func of int of int, right?
Beautiful.
And it even supports things like, so you could ask the question, what happens if you make it like an out parameter? What would you do then, right? Well, the compiler generates one on the fly because you can't represent the out parameters via a generic type. So it's not func or action. It's just this new
it's
anonymous
an apostrophe
delegate,
of a.
right?
That's
it's a anonymous delegate. There you go. What you couldn't do before, which maybe you didn't know, was you couldn't do this. And that works. Yay! Why is it important? Well, because minimal APIs, we wanted to support things like this. Let's say you had a page index that came from query string, and it wasn't there by default. You want to say the index by default is 1. So now this works as well. Great. Yay. Cool. Awesome. Small, but very nice feature. I think as part of the language design, we end up tightening up features over time. So you'll see a thing may come out in one version, and then you'll use it, and you'll find some edges, and then we'll kind of polish as we go by. So if you don't get kind of big features every single release, it's because we're working on that polish. Well, Matt is not me. I just complain to him.
Sometimes we just run out of time too.
Yeah,
and we
true.
We have to just draw a line and go, this is still useful, even if we can't yet use it for this other thing we wanted it for.
Yeah.
And then we add the thing, and then we can use it. So.
And I believe Mads has a talk on Friday about C#. So definitely go and watch his talk and learn about
tomorrow Friday. Tomorrow, Thursday.
Oh,
Thursday.
So it'll be Friday where we are.
I don't even try to attempt to figure that out.
Okay, runtime features. We're done with C# now. We're in the guts of the runtime and the JIT and the garbage collector. I only found kind of two main features that I think we
haven't talked about an awful lot. Yeah,
a lot of. There's this new GC mode called datas or datas.
I can talk about this one if you like.
Oh, perfect. You should.
Yeah. So as part of one of the projects we did in .NET 8, we had a project called Goldilocks, which was for ASP.NET Core. How can we kind of find that sweet spot for building really small, low memory use, low XE size ASP.NET Core apps if you're building like gRPC or APIs. One of the issues we hit very early was that server GC, which is the nice GC mode that does multi-core GC and all the wonderful non-pausing GC stuff for most stuff, was it uses a lot of memory. Because it sees you have 24 cores, and so it creates 24 heaps or half 12 heaps or whatever it might be.
Just use them.
Just use them all. I'm server GC, there's lots of cores. I want to do all the things to make your app run faster. So that's what it does. But then it turns out that when people run Hello World ASP.NET Core and they see on a machine with 24 cores, like a modern laptop, and they see it's using 400 megabytes or 500 megabytes or 2 gigabytes, they go, why is it using so much memory to do Hello World? And so this is our first attempt at basically tuning the server GC to instead say, you know what, I'm only going to create memory that I need if the app needs it. And then if the app needs it and then it doesn't need it anymore, I'll dynamically adapt back down. I'll shrink either my budget and including the number of heaps that I'm using. And so as a result of that, you can end up having apps that instead of using, like I said, gigabytes of RAM, might only use a couple hundred megabytes of RAM for the same load, right? The same amount of load going in the application. So this is only on by default currently in the new Web API native AOT template. But you can turn it on in any application. Okay, if you enable server GC, which is on by default in ASP.NET Core, you can set another flag that will turn this thing on. That flag right there, garbage collection adaptation mode as an MSBuild property, set it to 1, and you can try it out. Let us know how it goes. Our goal is for this to become the default mode eventually.
In 9.
In 9, hopefully. Yep. All right.
So that mode is funny because that mode came up in the very beginning when we were discussing the AOT stuff. We were comparing to Go, and we were being compared to Go. And Go is really good at not doing aggressive collection and allocation. Our GC is lazy and extremely efficient. That makes sense, right? Yep. You're lazy, so you're being more efficient because you're going to do less until you have to do more stuff, right? So this is one of our big attempts at making us by default kind of scalable up and down. That was a big thing for us. We have teams inside Microsoft that run on 128 core machines, and they will run one process, 128 core machines. Okay. Yeah, it's insane.
That's a lot.
And they'll run a single process in server GC mode, and that one process will assume 128 heaps by default, right? So we've gotten feedback over time that we want to be able to scale dynamically based on the load. That's what this feature is.
And to be clear, there are knobs already that let you configure how many heaps to use.
A lot of knobs.
Configure the size of each of those heaps, but that's a lot of knobs. And what if your app changes size while it's running? Like, what if you need to suddenly have more heaps? And then
it's magic sauce.
Right? So the whole point here is that we'll just figure it out for you. You just run the app and it figures it out.
Awesome. The other feature, this is a really interesting one that is like, wow, we did this one. So if
hey, who has ever done private reflection to get access to a member in code that you don't own? No, it's okay. It's fine. Who's ever used Entity Framework?
Whoa.
Okay, it uses private reflection to get access to code that it can't get to.
It does.
That's how it makes itself fast.
Remember the days of looking in Reflector on .NET Framework to figure out how stuff worked before we were open source, and you'd find all the code and you'd be like, hey, I want to tweak that field.
That private field, right?
And then you write code that is like what everyone does. You do type of like some class, and you find the class, and it's like in the IL decompiled, and you find the field name. You're like, okay, the field name is private field. And then you feel dirty. You're like sweating, and you're feeling terrible. And you get field, and you pass it in with a string, so you declare a constant, and it doesn't make it feel any better, but then and then you say binding flags non-public, and you've gone off the rails.
The fact that there isn't even a binding flags for private, because we don't want to say it. It's like, no. We feel so dirty saying it. It's like, don't ever do this.
It's non-static, so it's instance, and then you've done this, and you get the field info, and then you're like, I can now call like the actual internal fields. Let's call this. Does it have a value? Look at Copilot helping me out like already. Hold on. Why is it complaining about this? Oh, it's private. Let's make it public. Okay. Perfect.
Field.
Feels private. And so everyone's seen this code before. This isn't new to anyone, right? Don't feel bad if it is. This is awful. So I do this, and I should get back 42, right? Not surprising. Hello world 42, right? There's a new way to do private reflection. It's kind of crazy. Okay, so I can declare, let's see if I get the syntax right. I can declare an external method, all right? I think it has to be static. And it has to match, let me just look at the syntax. I'm not going to get this right. I'm going to get it wrong. So you can use this thing called Unsafe accessor to declare an external method with a string name on top of the actual method with an attribute, right? So I can say like, I want to get a private field, and I have an example here. Yeah, we totally messed it up. So here's the example. And I can't call it here. Let's just do public some class. So same idea, but different syntax. External method, ref, because I can set and get the field. And name the field here, private field is a string, and I just declare this method. And the runtime will do magic to implement this on native AOT, mono, core CLR. So you get this type safe way to do unsafe reflection. Great.
That keeps working even if you trim or you do native AOT.
That's right.
Or any of those things. Yep.
The reason we did this was because Entity Framework, or the driving reason we did this was because Entity Framework wanted to generate code at compile time that accesses your members, that you your entities that you declared, And today, it bypasses your properties and goes to your fields directly. If you didn't know it, that's what it does, right? So whenever you do a query with a projection, they'll instantiate your objects and pull your fields directly. It's super crazy, and it's very efficient. So they didn't want to lose efficiency. They ran perf tests, and the difference was like massive. Yeah. So the question was, how do we let any framework code generate static code that accesses private fields? Sounds crazy, right? So you can imagine
in a runtime safe guaranteed way.
In a runtime safe guaranteed way.
Right.
So you can imagine you have like a class like this, and you have a property like this. Behind the scenes, you get this underscore like brackets private field blah blah blah. Any framework will basically code spit those things into like these classes. So they will source generate all this stuff behind the scenes, and every runtime, even the AOT runtime, will support this new feature, and we can do type safe reflection.
Nice,
kind of incredible, right? Let me make sure this works first, just so you can tell I'm not a phony. All right.
You calling the new one now? Oh, wow, that was quicker.
Works super fast. We can tell. All right. Nice. Runtime over. We're halfway through.
Okay.
Pretty good. All right. Who has used Timer Provider? It is one of the best features in .NET. It is so good. Have you heard about it? How do you test things that use datetime.now? You don't.
Right.
You don't, right? Yeah.
You spin up a VM, you set its time to what you want to do for each test.
A container, not a VM.
Okay, container.
So you get Docker run, you configure, I'm kidding. So normally you would have code that was like this, and you were like, you want to assign the current time to your fields or your classes, so you would do this, right, in your applications. And obviously, anyone who's tested a timer or datetime has an iDatetime interface. Yep. We did a search internally at Microsoft. There were 1,000 iDatetime interfaces.
Like system clock, iFake clock,
there was
provider,
one ASP.NET Core.
Provider.
There were two in ASP.NET Core. A little bit of the same team over time. There was one in extensions. There was one in the runtime. There's one in everywhere. So guess what? It became this obvious need. We should have a timer abstraction, right? So if you want to test the passage of time, use this new feature called Time Provider, right? And there's one by default. There's, I think, Time Provider.default system. This is the default implementation, and you are supposed to build your own mock. There's also one in Microsoft extensions. I don't know what the name is. There's a mock we ship out of the box where you can kind of like manually advance time by saying like add hour.
Is it literally mock time provider?
It's mock time provider.
It is, yeah.
It is. So normally your code would be doing this. Instead, you will take in a time provider, P, and this, I guess this is the gross part. You can't just use your static method anymore. You can't use this anymore. So this goes away.
Yeah.
Right. So I'm assuming if you wrote testable code, no judgment.
You don't call any static.
Exactly. So you should be fine doing, hey, I have a datetime object, get now. Look at that. Perfect. That's not what it is.
Get. There you go now. And some other argument.
Why is this complaining? Oh, it's offset. Perfect. So you should be using this thing, and it's usable with timers as well. So I can create a. Has anyone seen my favorite feature from .NET 6?
From 6?
Your audit timer. This timer, where you can create a timer object.
How many timers are in the framework?
I don't want to talk about that.
Okay.
There were 2, and then we added one more.
Right. So now there are
7.
Okay.
So you can do this and just wait for a timer to tick. You can wait for next tick. Is that what it is? No, I see I have to do the await. I forgot to use this thing. I think it's like while. Yeah, there you go. So you can do this, and this actually will wait on a second, or you can say pass in the timer provider, P, and if you have a mock one, it won't fire until you advance the time by hand. So the idea is you author test, you author all your code to inject the provider, and then your test can just have a mock one, so you can kind of advance time by hand. It's super nice. Things that support this also, task.delay. Everyone is doing this in their code when they want to like get more money, so you put a fake sleep in. And then when the boss says you got to speed it up, then you go, I got you, boss. From days, one day. and then you pass in the provider.
It just looks like my first workflow. Step 1, wait a day.
So task delay supports the time provider as well. So does cancellation token. So we kind of went far to figure out what things in the BCL people end up using. That anything that does new timer internally, we now support passing in this from the outside, so you can kind of mock time. Right. Super good feature. Cancellation token source now takes in a timer provider. There it is. Time span delay. So time span from seconds 1, and then you can pass in P as well. So change all your code, all of it, and flow this thing everywhere, and then you don't have to worry about testing later on. Awesome, because flaky tests suck. We have tests that need to wait for the entire timeout to fail. It sucks. So this is kind of the way to fix that. All right, random.shuffle. You want to talk about this one? This is one of your favorite.
Oh, look, 10 seconds. There's just someone did the work to add nice methods on the random class, so that if you've got an array of values and you want to get a random value out of it, you don't have to write that code anymore. You just say shuffle the array, please, and it reorders it randomly. Or you can say get me a random value from it, and it'll get you a random value from it. I just think that's so cool.
Is this nice? It's a nice feature, right? Just shuffle the array.
Yeah.
I mean, this isn't useful because I can't actually get it back, but I should probably declare it first.
Yeah, well, yes. You just shuffled an ephemeral array that just disappears again. So you're just doing work. Put that in a loop and replace your timer delay for 1 day before.
Let's see what happens.
Make it do something.
There's a sort called sleep sort.
I mean, you could implement a dice rolling method with that, what you just wrote, right? Just shuffle this sequence and give me back a random one.
Do it, Copilot. Do it. All right.
Nice.
Shuffle works. Boom.
Yeah. 5514. Run it again.
Shuffled.
Yeah. 4214.
This is how you trick the interns. You shuffle the array and see what they do. All right. There's also get items.
Yeah.
Which gives you back a random
set. How many? Yeah.
So let's see if I do this with 1. It's not super efficient. What do I pass here? Read-only span of choices and a length or destination. This is so you don't allocate the return array. Right? So you can say,
pretty cool.
Given this list of choices, push it into this span so there's no allocation at all.
Randomly.
Yeah.
Get me a random 2
subset from
into this other thing
list
with no allocations.
Yeah.
Very nice.
One thing you'll see in new APIs, we are thinking a lot about low allocation APIs. There's also the convenient APIs that do allocate. So there's get items that have to create an array returning, and there's also get items that fills in memory. It's a brand new pattern that's very much like C. The C and C#.
But you have choices now. You can do it.
Yes.
And span makes it much easier to do.
Frozen collections. Who's heard about frozen collections? Yeah? Good, right? So that actually came from the Teams team. The MS Teams backend team. They were trying to optimize a bunch of their code that had to read some config object at startup, and then it would they wanted to optimize for lookup
later
on. So they had this one-time expensive read at startup, and then you basically crunch the array or dictionary or set into this super optimized lookup system. It's not immutable. It's frozen. Confusing, right? Frozen collections cannot be changed. Immutable arrays can be changed, but you get a new array after the mutation. That's the main difference, right? So hopefully that made sense.
Have we changed any of the code in ASP.NET Core to use frozen stuff yet?
Some. I believe we changed a couple of things to use frozen dictionary.
But there's a bigger upfront cost, as you said. The startup cost is higher, but then every read is much quicker.
Exactly. So it's optimized for reading, and you are paying the cost up front to crunch and figure out what the data is. So you can say, list of strings, do this, ints, do this, optimize for this algorithm, this hash code. If you have a small set, use a super perfect hash. If you have a big set, do something else. So you're paying this big cost up front to create the collection, so that reading is super efficient.
Okay.
Yeah. It's a crazy indexing collection. Very, very cool feature. All right, composite format. This is kind of a... Let me move this.
I don't even know what that one is.
This also came from the Teams team. The idea here was when you do this code in normally string.format, right? Nope. Close. String.format. I say hello. Oh, nice. Hello world. This is, it got better in .NET 6, I believe. Okay, this is a slow one. This is not great. This code is doing a parse of the template every single time, finding the 0, getting the values as an object, and then filling in the hole and making a new string, right? It's fine, not so bad, but it's not as efficient. This code, let me just get a variable so it's like not crazy. What are you doing, Copilot?
It's like the most eager puppy you've ever had, isn't it?
This code, since I think C#6, tell me if I'm wrong, someone, it looks similar. It looks like the same thing, but the compiler is breaking this into a series of calls to like append, and it allocates one final string. It is insanely efficient, right? So they're very different things, but you have to do the first one if you have a string that comes from somewhere else. So you're loading things from a database or resources, or you have like a bunch of format strings that are external to the application. So the compiler can't optimize this call by doing a straight inline parse of the template, right? So the goal is to split up parsing from filling. So there's a type called composite format where you parse a template. So you give it this string format template, and you basically are getting a format that has a hole. It's a pre-parsed template, right? It's not a
donut template.
It has holes in it. Yeah,
right. It's a hole.
It's undone.
Oh, I guess you could have
this is one hole, but you
this
can
is one, but you
n
could have
holes.
multi-hole.
And then there's a string format overload that takes. Oh my gosh!
It really wants a for loop.
It's not a for loop. Like, what are you doing? There's this. Wait, where is the overload? String format. Oh, wrong way. So culture info dot invariant culture. Perfect. So pass in the culture info, pass in the template that's pre-parsed, so you don't have to reparse the string every single time.
Nice. And
the value gets filled in. It's super efficient. I believe there's overloads for up where it won't allocate for 3 arguments, and then tough luck. Yeah. There's a trade-off between having like T1 to T50. Like there's just a lot of memory and other trade-offs and size and generics and question. Correct. Good question. Is this how logging works? When you grab, let me jump to ASP.NET Core. When you grab an iLogger from DI is a program, let's see, logger here. When you grab this and you log some string like logger.log, go Copilot, go finish me. Hello, name, and like, let's say you get a name. This comes from the query string. Almost. Perfect. What happens when you do this, right? Same problem. You get this call to log. It has to parse the thing every time. We do some insane things, but in .NET 7 or 6, I don't even know what's going to happen.
Yeah.
We actually re-implemented this with that new primitive. So we actually parse this template into a composite format under the covers. And if you have up to 3 arguments, then you get the perf. Otherwise, it'll box and a lot of bad things. But yeah, we actually, and that's probably a pattern where if we add a new primitive, we will do our best to use it everywhere in the same release. So we can find problems and see if it works in practice. So yeah, that happens in the covers. It's still parsing every time because it's string is here.
Yeah.
But there are ways to kind of like pre-compile and say parse once and then do it over in logging.
With the logger generator that we released in
6 and 7 and 8.
Kept updating them.
All new versions, new things that came out. All right, on this same trend of crunching things up front to then make it fast for reading at runtime, there's this new feature called SearchValues. Has anyone seen this feature? SearchValues? Phil told me before that I know everything in this talk. I said you don't know. SearchValues is the same pattern that we've seen with frozen collections and with the composite format, where you want to do a fast search at runtime or many searches at runtime on some body of text. So you want to say, I'm going to look for, I don't know, like their byte values.
Ampersands.
Ampersands. I want to scan for new lines, right?
There you go.
Or you could pass in an array of, is it an array of values? It's an array of values. Go C#. Yay. And we will do our best to observe this array of values passed in And we will give you the most optimized searching algorithm that we can figure out under the covers for the payload passed in. And it does some insane things I learned in computer science, like way back when, that we kind of like brought back in, just to give you a sense of what it does. Like, okay, that's not helpful. Let me just show you, because I use this all the time. Does anyone use source.net?
Every day.
It is amazing. It's this entire index of the entire .NET code base that is like insanely fast. Search. If I could type.
Okay.
How dare you? All right, so here is the create function. Like, you won't understand how insane this is until you see the implementation. Create values. If it's empty search values, not a big deal. One value, you do a 1-byte search. Try to find out if you're in the ASCII range. If you're less than 5, optimize this. And this is like super vectorized and optimized. So like, we spent a lot of time trying to optimize for all the cases that we saw in our code base. If you're ASCII and you support vectorization and the value is less than 128, you can do this super optimized thing. Or if you're just bytes, do this thing. So there's this pattern that we're making of do all the work up front to look at data and figure out how best to optimize the algorithm for runtime, and then make a really fast, efficient thing. And you use this by calling index of on different things. So I think for this one, this is a byte array. Let me just B, whatever. I said B and I wrote X. Is it as span? Span.index of. I believe you can pass in a search. Oh, how do you use this thing? I forgot how to use this thing now. Failing horribly. Search values. You pass it into something. Where do you pass it into? Values. This doesn't have any functions. Like, all it has on it is a call to index of and contains. And then when you call index of and contains, it defers to the implementation.
Mm-hmm.
If I can find it. No. Can't find it. Go read the doc. I figure out how to call it. Yeah. You might be right. There it is. Okay, so index of does not have it. Okay, that's right. Perfect. And this indirectly calls the underlying search values. And you can do it for index of any, and there's except, and there's do you want to find the thing in, or do you want to find any that's not in the thing? And it's used, we replatted our HTTP parsers. Every parse that we have in the VCL got replat on top of this JSON, regular HTTP, regular expression, regex, everything got replaced with this thing. It's insanely efficient. All right, 16 minutes. Let's see what we should jump to that's actually interesting. This is two. Anyone does like hashing of stuff where you like SHA-256 and you pass in the byte array? I think this is not new in 8 potentially, but there are one-shot hash functions where you pass in the entire blob. It's a static function, and you just can say like, do the thing and come back and give me a byte array. And there's overloads for passing in a span and right into a span. There's overloads for like passing in just a blob and getting an array back. That's less efficient, etc. There's a new interface. This is a super low-level API. If you need to format primitive types to a span, a UTF-8 span, you know how you can do int.parse, and you can pass in a string. So in .NET 7 or 6, we added support for passing in a UTF-8 char. So you don't have to allocate a string to parse it. You can say, like, given this big piece of text, find the number 200 in this text, and then get a sub-span without allocating, and then parse the int. Right, so no allocations. That was done for chars, but not for bytes. Or is it cars? It's chars. Chars and bytes. I agree. So now we have this new interface that we implement on all of our primitive types.
Lots of interface. There it is. Yeah. Well, that's the old one, span formatable, and then there's UTF-8 span formatable.
I don't know where it is.
Well, you had to keep going, I think.
Or it could be a UTF-8 span parsable.
Because it's the other type, right? There's two sides. Like, am I parsing from UTF-8 or am I writing out to UTF-8?
Right, so there's produce me this value as a byte array or a char array or a string. And then there's given an input char array or string or byte array, produce me the actual value.
Right.
So there's these two interfaces to go back and forth between those.
We had one in one release and not the other. We did one side and we didn't do the other side. Now we have both sides. And it's really useful if, like me, you've got a little class library, NuGet package that you want to write out really efficient Razor templates to a UTF-8 stream. Now I can just use this to do it rather than doing it manually.
That's awesome.
Yeah, it's great.
Extensions, let's talk about some of the big features in extensions that you may have seen. Keyed DI, has anyone used Keyed DI?
This is a big one.
This is a huge feature. I think people either love or hate it, or hate it. I think it should not exist, and we're awful for doing it. I mean, we held out for a long time. So
we held out so long that we reinvented it numerous times in the subsystems that needed it. So you might have heard of named options.
Denial.
Which is built on options. And that's because we didn't have Keyed DI. So we had to have a different version of options so that you could name them.
It is insanely useful, Keyed DI. If you haven't used
it,
there's now overloads for adding services. So let's add scope. There's add keyed scope, add keyed singleton, add keyed transient. And the only difference is you can pass in a key, which can be any object. And you can then call get required service for an interface, passing in that key. So I can say, add me an iLogger, and use the key foo. Oh my gosh. Copilot has lost his mind. Logger thing. Just a fake logger, just to show the idea. Yeah, it's not working. Right, so I can say the big benefit is you get to use the same interface and not change the interface, which is super important if you don't own the interface. So let's say you have a thing that came from somewhere else, HTTP client, and you want to get a different HTTP client based on the target backend URI. So I have one called OpenAI. Now I can have HTTP client for OpenAI. I can have one for different things.
Which of course you can do because we wrote
a thing to work around it.
Because this feature didn't exist. So we wrote a thing.
Exactly.
But now.
So this lets you use the DI container as a factory without having to work on it with your own factory.
Right.
For things that have both an interface type and strings, and a key.
Right. You might want to, if you're using something like Dapper, the data access library, not the distributed systems. Anyway, you might want to input like a SQL connection into DI, like a SQL connection factory, but maybe you've got 2 database servers. How would you do that today? Well, you can't. You can't put SQL connection in twice.
Make your own factory.
You have to wrap it with either a wrapper type for each one, or you'd have to create your own factory type that you pass a string into or some type of key to get out the one that you want.
Right.
Now you can just
And DI is a factory, so you should be able to use it like
as a factory.
So you can say, yes. Whenever you add if you call add keyed blah, you can name the key you want to name for any clients. You can call any of the Aspire components multiple times, and we'll add different clients with different settings, and they vary by keyed server. So yeah, it's being used for that. One novel thing that I've been trying to do with keyed DI is do multi-tenant DI using a key as a tenant ID.
Yep.
So you can have the same services, blah provider, but scope per tenant by using the tenant ID as the actual key. So you can build pretty insane gnarly things by having this keyed DI.
Whereas today, most people implement that by literally overriding the entire
collection
per whatever, per request. They figure out who the tenant is, and then they go, well, I'll create a new container from my collection just for this tenant.
Orchard.
Yeah, Orchard, for example. Yeah.
Is it better? It's a factory.
It's exactly that.
Yes, it is. And I think that's the point. The point is before you could do this same thing if you built your own factory, your own bespoke factory for every single interface type. This is just the DI container is the factory, and here's how you get things from it, and you get the whole benefit of the performance and stuff that it does and it covers. So,
yep, cool,
really cool feature. We don't have lazy yet.
Nope. And we haven't updated all of the subsystems.
Ever. I'm kidding. I should say ever.
We don't use keyed services. We didn't retrofit keyed services into all of 8.4 yet.
Yeah.
We're trying to use it for new features that we built in 8, but there's still work to go back and retrofit it. So,
all right, 10 minutes. I'm going to jump around like crazy now.
Yeah, jump around.
Config source generator. This one is, I don't have to show it. When you do something like this today, which everyone does, I've seen you do it. seen all your code. If it's on GitHub, I've seen it. Options. So here is your app
settings,
app
options,
right?
whatever. Yep.
Let's call this key. Int key, whatever.
Client secret. Password.
Over
Password in
engineered. Can't be a string.
Yeah, thank you.
Oh, almost. Oh, close. So I'm going to bind this up. What's going on here? What are you thinking about? Oh, gosh. Get. You can do stuff like this and pass in a config section. No options. I think I have to call get section. App options. .get, right? You can do this, or you can bind by making an options and then calling bind and passing it in. Very common pattern when you're doing ASP.NET Core, right? This does not work in native AOT. What happens under the covers is we have to look at this config section, look at this type, reflect on all the properties, and then poke stuff into fields using reflection, right? So recurse, find the object graph, and like do the thing you do normally. The source generator lets us take this and do it at compile time. And we magically use a feature in C# 12, interceptors, that is amazing, that will sneakily replace this line of code with one that is code gen at compile time. So we'll grab your object, and we will say, this is a get method, and it takes app options, and it will generate a method that is an overload, that is the exact mirror of this function, and it will spill all the code that does the reflection at compile time. So it's super efficient, and we turn it on by default when you turn on AOT. But it's usable without AOT as well. So if you want to turn it on, there I believe is an entry in configuration. Let me find it. Source. No, not com. There's one for com too if you want to use com.
MSBuild property, right? In your project file?
Let's make this compile first, so you're not shouting at me. There's this.
In theory, that would be a little bit quicker too, right? From startup, less reflection.
It should be yes. No reflection.
Yes, less. None being less.
Is that 12
yes.
work? If you make F12 work still, is it on? Is it working? Is it doing stuff? I can't tell.
Says succeeded. Move on.
Yeah, move on. It works. Promise. Promise.
There's no errors.
All right, so 7 minutes. We can do I-hosted. Has anyone seen the I-hosted lifecycle service? It's pretty important.
Everyone, if you write a hosted service, you have a thing that you want to run in the background of an ASP.NET Core app or a worker service. So you write a class, you add it to DI, it implements I-hosted service, and then it gets started up and called when the app starts up, and it gets called when the app shuts down. We added more lifecycle events because sometimes you want to be able to say, yes, I want to get called when the app is starting, but I don't want you to continue starting the app until I've finished, right? Whereas today, I think I-hosted service before that, there was only one hook and it would run them in parallel. And there was really no way to kind of compose and change the order. So we added more lifecycle hooks. And now you can get called back. You can implement both interfaces because that does it for you. And you get more methods. Started. It's not in like chronological order. It should be like started, and then stopping and stopped.
Yeah, fun story. We couldn't agree on having multiple of these. So what happened was people wanted to have different hosted services depend on each other.
Right.
We're desperate. Different teams built services. I want to run before that team service. That's hard to do. So we just built this thing instead. So you get more chances to run at different phases. Right.
So now at least you can figure out if they're running on that one, I can run on the one before that.
Yep.
Or the one after that.
Just use communication.
Classic lifecycle problem.
Yeah, very difficult. Awesome. Let's amp it up. Okay, so let's look at some boring, I'm kidding, not boring stuff, no.
So just to finish it, the one reason I wanted to use that one, has anyone ever written code to pre-warm up a cache in memory in their ASP.NET Core app, and they would like the app to not start until that cache is warmed up? This is what you use, okay?
Before start. We should call it before start.
Maybe.
Starting or before
Let's not black shadow the name now. We shipped it already.
Damn it. We shipped a feeture, by the way, just I'll rant. There's a feature called iService Provider is Service. Can you believe it?
Yeah.
It's embarrassing. It's embarrassing. What were you thinking?
That was a placeholder name.
It was a placeholder name.
And then we looked away, and it became the real name.
Everyone tapped out. If you do anything on the CLI in .NET, you can actually get JSON back from the command line.
Oh my gosh, this is like an amazing feature. I forgot about this one.
So it might look super lame, but look at this.
So does everyone understand what that means? What that did? Okay, so MSBuild is an engine. It goes through phases, right? You have this evaluation phase and then this execution phase. If you want to coordinate or orchestrate
or get
an MSBuild thing
or get data
with something else, right? You want to say, I want to do this thing, and then I want to know what the value of that thing was inside the orchestration so that I can then take that and run a different script with that value. Before, you would have to write your own target, compose it into the build, like past targets, have your target evaluate at the right time, and then output a JSON file or something that you know how to read. Ask me how I know. We did this in our own tools. This is how like the Razor compiler and stuff work. Now it's just a generic feature in MSBuild. You say, I want to run this target, publish in this case, and then just get this property. You can also get items.
I know.
So if you want to enumerate all the things, like all the compile items, get all the references out, you can say output items. It'll give you a list, if I recall.
Yeah.
Yep.
Let me try this one.
It's super, super cool.
Docs. Let's try it. How many of you have parsed the XML in MSBuild? Yeah.
Which, of course, is generally wrong.
Doesn't work.
Because it's not static, right? It can change. It's an engine when you execute it. Look at that. JSON, no less.
Oh, amazing.
Beautiful.
Hopefully, you've all seen .NET Container Publish. You can publish a container image to the local Docker daemon. I'll just do a .NET Publish. This is the old one.
It still works, but yeah. That one works too.
So you don't have to have Docker files or Docker installed. You can kind of just build a container image natively in .NET.
Your / is offending me. That could just be a
Too
dash.
bad. Too bad.
It could be a dash.
Oh, Pilot said it's better.
That wasn't.
The AI, I believe, the AI over you. What does?
Yes.
The get property?
Yes.
Yeah.
So absolutely, because it literally runs the target as it would normally have run, and then just outputs whatever you asked for. Oh, publish doesn't?
Docker
okay.
file?
Yeah, so the Docker, inside the Docker file, in order to, when you do, you get references, you also need your props file.
Oh, if you're doing a Docker-based build, you have to copy from the host into the container so you can do the build and then copy out. Yeah, well, there's no Docker file here.
This container build is magic. This is using
no Docker file.
tar APIs to produce the image format. There is no Docker involved or files involved.
So to be very clear, this is for the circumstance where you have no need to use Docker locally just to build. Like I have all the things I need. I just need an image out of my build. I need a Docker container out of it. Now you don't need a Docker file to do that. You can just say .NET Publish, make me a container. Okay? And so if anyone who saw the Aspire demo this morning where he ran AZD to publish to Azure, it used both of these features in order to get the container out. It evaluated MSBuild stuff to get a JSON file, then used that to compose the rest of the steps, including publishing directly to a container registry.
There's a feature where you can get the actual container file, the tar GC archive for a container image. So I'll just copy and paste and do this one. Containers are not magic. They're just a format, a file format. Why did it have to do the crazy thing? Let me just edit. Nope. Super top secret. Super top secret. Delete. That's fine. It's all temporary. This is not a Windows thing, is it? Let's see if this works.
MSBuild will normalize the paths for you, so you're good.
My God. So I have this thing in images. So if you want to run a bunch of tools on the container before it gets published to the registries, you want to run like security scanners or whatever you want to run on these images, you can now produce the image before it gets published to run more stuff on it. Beautiful. Natively in .NET. There's no time left. There's a ton of features. Let's just look at a slide and I'll just smile.
There's all the ASP.NET stuff we like. Thank you very much.
Jimmy rendering. 3, 2. Oh, man, that was good.
Ooh, I forgot about that one too.
Which one?
I'm looking at this and I'm going, oh, that's right. I forgot we did that. That's awesome. I authorization requirement data.
It's good.
That's really cool. Did we doc that really well?
We did.
Okay. Go and look up for that one. If you've ever done any custom authorization policy stuff in ASP.NET Core, this will make your life easier. Go look at authorization requirement data. Yeah, generic attributes. We updated all the attributes to be generic. I forgot about that too. We did so much cool stuff this last year.
Polish. Polish. It's beautiful.
All right.
Awesome.
Thanks all. Any questions? Ask a question. It's the end of the day.
Yeah, we're done.
What do you want to know? Nothing?
Let's keep coding.
Oh, on the slide here, improved debugging. Yeah, that's a really good feature. So we had one of our developers, James Newton King, the creator of JSON.NET.
We call him Jason.
Call him Jason. Jason King. He got inspired one day and just went off and like updated all of the core types to have better debugger display visualizers in Visual Studio, or debuggers that support that. And so, yeah. So once he
was so proud.
So now, if you take in like HTTP context and you want to look at the context while debugging, usually today what would you do? You go down to like the locals window or the watch window, and then you'd scroll to get the most basic information. Now you can just like hover over it, and it tells you.
Look at that.
Look at that. Tells you the path. It tells you
huge.
the 200 OK the state. It's really, really cool.
It's huge, and he changed types like in the BCL. He changed types in ASP.NET Core and EF. Like,
look at the connection. Look at the connection. Look at the top. It's giving you the connection ID.
And the IP addresses by
beautiful.
default. You get
number of features. Oh, it's great.
A lot.
It's a lot of stuff in there.
We should trim that.
So that's what that is.
Features 26. Like he tried here, but we can do anything. Items, requests. Look at all the cookies, path, scheme. Yeah.
Very nice.
Very cool.
Yeah. Anyone else?
Everyone's tired.
Everyone's tired.
I get it.
End of the day.
I get it. Say what?
Form binding.
The big feature is form binding. So before we had in .NET 7, you can do this. You can do from form, and you could say like string s, and this would, if you did a form post, it would bind this field. All right. This is kind of lame. You couldn't do objects. You couldn't do classes. So you couldn't do something like, I have a form that's like person form. Go, Copilot. Go.
Yes.
Do my bidding AI. This works. Now. And it has anti-forgery support. Thank you, Phil. Thanks for the clap.
It is not MVC model binding. It's not like a super complicated list that you can dynamically change. It is what you would have written by hand to make that work. Like it's that, right?
I think what's insane is we essentially, one of our engineers went off and wrote an entire serializer to make this work. Like in a couple of weeks, he's like, "Oh, I have a thing." Huh? Where? So
there it works, and it's shared by the new Blazor
and
features.
Yeah.
So if you're using Blazor 8 and you're doing form handling in Blazor 8, like not using server interactive or client interactive rendering, you're just doing normal Blazor in Blazor 8. It's using the exact same form binding under the covers. The question is, what if the property was an int, but you pass a string?
Thanks for coming.
Well, everything's strings. But you mean a string that's not an int. Can't be passed. It explodes. You get a parse error.
Oh, you get an error.
You'll give an error.
Yeah. You get a 400. There's no model state. No model binding. There's no model state.
No model state.
It's efficient. It's efficient, Phil.
Model state is expensive.
It's very expensive. Well, this can't go here. You get what you deserve.
400 because you sent me a bad value. It's your
400 your fault, 500 my fault. Of course not.
No, because that would be
disclosure.
You could write a filter.
We got our bases covered. We're like security. Yeah.